Have you ever really stopped to think about what happens when you flip a light switch? Well, we're about to go on this incredible journey. We're going to follow just a single drop of water as it transforms from, simple liquid into the very electricity that's powering our lives right now. Honestly, it can feel like pure magic. You hit a switch and boom, the room is flooded with light. But behind that super simple action is this really elegant and incredibly powerful process. So the big question is, how exactly do we turn plain old water into watts? Okay, so this diagram right here, this is gonna be our map for the whole trip. Now, don't worry about all the technical lines and numbers on the graph itself. Just think of it as our blueprint. We're going to follow one water droplet on what is basically a wild roller coaster ride through insane heat, pressure, and speed, all to generate power, before it ends up right back where it started. It's a perfect loop. Every great journey starts with a single step, right? Well, ours begins with a single, powerful push. And that first push comes from this guy, the pump. If you look at our map, this is the jump from point 5 all the way up to point 6. You can think of the pump as giving our little water droplet its call to adventure. It takes this calm, liquid water and pressurizes it, getting it ready for the intense transformation that's just ahead. Now that it's all pressurized, our water droplet is heading into the very heart of the power plant, the boiler. This is where the real magic happens. This is where it's going to undergo a complete and total transformation. But this change doesn't happen all at once. Oh no, it's a very precise 3-step process. First up, the economizer gives the water a good preheating. Then, the evaporator. Well, it does exactly what it sounds like. It turns that hot water into steam. But the real game changer is step 3, the superheater. This thing just cranks the heat and pressure to absolutely extreme levels, packing that steam with an incredible amount of energy. And all of that action, it takes place inside this thing, the boiler. I know it might look like a totally complex maze of pipes, but you can just think of it as a massive, super high-tech pressure cooker. It's perfectly designed to pull off those 3 steps and create some unbelievably powerful steam. So, our humble little water droplet is now completely transformed. It's not even water anymore. It's superheated steam. That's point 1 on our map. And it's just shimmering with raw energy, totally ready to do some serious work. And that work is about to begin. So welcome to the main event, everyone. This is where all that energy we've packed into our steam is finally going to be unleashed. Meet the steam turbine. The concept here is just beautifully simple. That superheated steam blasts through it, pushing on these blades and causing the entire shaft to spin at incredibly high speeds. It's really just like a hyper-efficient industrial-scale pinwheel. Now, to squeeze every last drop of energy out of the steam, the turbine is actually split into different stages. The high-pressure turbine gets hit first with the most concentrated, powerful steam, so its blades can be a bit smaller. But as that steam expands and loses some of its punch, it moves on to the low-pressure turbine, which has these enormous blades. They're like giant sails, designed to catch every last bit of force from the now weaker steam. And check this out, here's a really clever bit of engineering. In between those 2 turbine stages, the steam is often sent through something called a reheater. On our map, that's the little trip from point 2 to point 3. It's like a quick pit stop for an energy drink, It gives the steam an extra kick before it hits those big, low-pressure blades just to maximize the power output. And right here, this is the moment of creation. That spinning turbine shaft is connected directly to a generator. As the turbine spins, the generator spins with it, and through the absolute wonders of electromagnetism, it converts all that rotational, mechanical energy into the electrical energy that then flows out to our homes. That's it. That's when electricity is made. So our steam has done its job. It has spun that turbine and made electricity. Now it's exhausted, low on energy, and its journey is almost over. It's time to go home. After leaving the turbine, the Tynard low-pressure steam enters the condenser. You can see this as the step from point 4 down to 5 on our map. Inside, it flows over all these pipes filled with cool water, and that causes the steam to rapidly cool down and condense right back into its original liquid state. The transformation is totally reversed. So you might be asking, where does all that cool water come from? Well, that's the job of these iconic cooling towers. They take the water that's been warmed up by the steam in the condenser, cool it down by letting it mix with the air, and then send it right back to do its job all over again. It's a perfect little system within a system. And just like that, our droplet is brought full circle. It's returned to its liquid state, and it's ready to begin this never-ending cycle all over again. Let's look at our map one last time, because now you can see the whole elegant cycle. From the pump at point 5, it goes to the boiler to become superheated steam at 1. Then it blasts through the turbines from 1 to 4, then into the condenser, and finally it returns as water to the pump at 5, ready to make the exact same trip all over again. So let's just put it all together one more time, nice and simple. A pump pressurizes the water, a boiler creates super steam, the steam spins a turbine, the turbine drives a generator creating electricity, and finally a condenser turns the steam back to water. It's just a perfect, powerful loop. You know, this fundamental cycle, turning heat into motion and motion into electricity, it's the engine that literally built our modern world. It is such an elegant solution that has served us well for over a century. So the only question now is, what cycle is going to power our future?